Here we'll see how gRPC works, and also we'll see how to create a gRPC server and a gRPC client using Java. gRPC is a remote procedure call framework initially developed by Google but now available as a open source framework. This framework is built on top of HTTP2 protocol. This provides multiplexing, header conversion, reduced latency, etc. that is available with HTTP2 protocol. It supports multiple languages. That means if you are writing your server in Java and if you have Python and Java clients, it's easy to build with gRPC. It supports streaming like client streaming, server streaming, and bidirectional streaming. This is used when we have to upload a large file, or we want to download a large file, or we have to do both. It also supports TLS and various authentication mechanisms like JWT, OAuth, etc. Now let us see how this multiple language support is built on gRPC. Before that, let us see what is a protocol buffer or protobuf. Protocol buffers are language neutral, platform neutral, extensible mechanism for serializing structured data. What that means? Here an example is given. I have a Java object employee and it has name, age and employee ID. But I want to send this object to Python through RPC. RPC is a remote procedure call. That means you send data like a function call. So in Python, we need to get that employee with name, age and employee ID. One problem with this is Java has its own definition of what is a string, how many bytes constitute a string. Then age is a integer here. Integer is defined with how many bytes. Long with how many bytes. All those are defined by Java in the case of Java. Python also has its own definition. That means all these type definitions are specific to the programming language. If you want to send one object to the other, there should be a standard type definition. That is what our protobuf will do. Protobuf is a interface definition language. Protobuf has its own data type defined. First, what we'll do is we'll create a protobuf file. Protobuf file we'll create with a .proto extension. There we'll mention the syntax, that is which version of the protobuf to be used. Then there are so many configurations. For this example, we can see that we have a message employee. Message means we are defining a data structure there. Protobuf has a type called string, name is string, and its order is 1. That means it is the first field. Then int 32 age, that is the second field. Employee ID is int 64 and its order is 3. That is what we define in the protocol buffer. Then there are tools that we will use. For the gRPC, we have gRPC tools to create language specific stubs. These language specific stubs, what it will do is it will have the code or libraries to convert a Java string into a protobuf specific string and serialize the data. And the serialized data will be sent to the other language application. In this case, it is Python application. There, the serialized data is deserialized into Python specific object. Then the response will be serialized and send it out. That serialized data in the Java side, it will deserialize into Java specific object. That's the way the data communication works. If you want to know more about protobuf, the link is given here. You can visit that site and learn more about protobuf. This is an example of a gRPC protocol buffer. Here, same syntax we will mention. Then we have seen that there is a service object there. This service means it defines function call or the function that is used to send data to the other side. Here we are saying that the RPC function is add employee. It has a parameter employee and that will be sent to the server side. Then it returns an object called status response. So whichever application calls the server, it will send an employee, it will get a status response object. Since we have defined the objects here, we have to define what is the structure of that object. We are saying that message employee and it has name, age and employee ID and its specific types and the order is defined here. Same way, Status response type is a complex object again, and it has two fields, status code and description. Now let us see how the gRPC actually works. First, what we'll do is we'll create a protocol buffer file. We have seen the syntax in the previous slide, and the same way we'll create a file with extension .proto. Then using the gRPC tools, we generate language specific stubs. Here we are creating a Java stub, a Java library will be created. Then for the Python library files will be created. What we want now is we need a server and client. Client will call function in the server. Server will process the data and send back the response. We are creating a Java gRPC server here. That means we have to add the Java stub libraries here in the POM file and add the server specific code there. For the Java client, we'll have to again add the stub files, then create the Java client. Same way for the Python as well. Next, Java client will do a RPC call over HTTP tool. It will serialize the employee object and send it to Java server. Java server will process it and create a status response object, serialize it and send it to Java client. Java client will deserialize it and create the object and consume it. Same way, Python also send the employee object. It's a serialized employee object sent to Java server. Java server will deserialize it, process it, and send status response in a serialized manner. This will be serialized in the Python client and will be consumed. This is the way a gRPC process works. Next, we will see how to create a gRPC server and client using Java.